Good evening. This is BookSight, my daily podcast where I read a book. This time I'm reading a book titled Power and Prediction. If you're here for the first time, welcome and please consider subscribing my channel and my podcast page. If you're here because you like the previous episodes, welcome again. Every day I read a little bit of this Power and Prediction book and share my thoughts and comments, and I will encourage you to start a conversation here too. Let's make it a conversation. We want to sit down and talk about AI based on Power and Prediction book. Okay, so let's start. The part today it's titled Artificial Intelligence is Prediction Technology. In our first book, Prediction Machines, we examined the simple economics of artificial intelligence. We took all the potential complexity and hype regarding AI and reduced it to a single factor, prediction. Reducing an exciting new thing to its less sensational essence is a key tool in an economist's playbook. When people think about AI, they think about the intelligent machines littered throughout popular culture. They think of helpful robots such as R2-D2 or Wall-E. They think of brilliant teammates such as Data from Star Trek or Jarvis from Iron Man. They also think of those that turned rogue like HAL 9000 from 2001 or Ultron from the Avengers. Whatever their quirks or intentions, these representations of AI have one thing in common. No one disputes that they can think, reason, and have agency just as we do. We may develop technology that does all of that, but that isn't what we have today. What we have is an advance in statistical techniques rather than something that thinks. But the advance in statistical technique is very significant. As that advance reaches its potential, it will dramatically reduce the cost of prediction. And prediction is something we do everywhere. The signature event in a recent development in artificial intelligence was the demonstration of the superiority of new techniques in machine learning called deep learning. In 2012, a team from the University of Toronto, led by Geoffrey Hinton, used deep learning to dramatically improve the ability of machines to identify what was going on in images. Using a data set of millions of images called ImageNet, teams had, for a better part of the decade, tried to devise algorithms that would accurately identify what an image was showing. That dataset had already labeled each image with a human classification of what was in it. The idea was to take the dataset, use it to develop an algorithm, and then feed the algorithm with new images. There would then be a horse race between those algorithms and with humans who would identify what was in the images. The humans weren't perfect at this task, but before 2012, they were far superior to any algorithm. In 2012, that began to change. The deep learning approach conceived of the task identifying the subject in images as a prediction problem. The goal was to be able to predict, when given a new image, what a human would say was in the image. When presented with an image of a puppy, the task was not to understand what really made an image of a puppy. Instead, it was to guess what the thing in the picture was most likely to be among all the labels that existed. The goal was to guess the most likely correct label, which became the prediction. By allowing for a large number of attributes and their combinations, a computationally difficult exercise, what the Toronto team showed is that deep learning could outguess any other algorithm and eventually most people. This description can make it seem like what a machine was doing was winning it. rather than working through a problem. But it's winning it on steroids. Machine prediction is useful by being more accurate than anything else. The reason is that predictions are key input into our decision making. This part of the book made me think about why people want to predict and why actually looking for a great use case around the prediction is a great thing. I personally think that people always want to predict weather, stock prices, the next cyber attack, or how much money they should keep on an account to make sure it's an optimum amount. People also want to predict when the machine will break or when the particular group of customers will leave the company and go to competitors. And we always wanted to do that. And we can do it for good. Like we can predict how many people will get to the emergency unit and get more doctors on the shift, or send emergency EMS cars to the different emergency unit to make sure that those patients that are actually waiting for a care will not wait too long. We can predict when the next newborn baby will require a special equipment for the first 2 weeks of the newborn life. We can predict when the elderly person enters the apartment needs a light to be on the voice to guide this person to the particular appliance in the kitchen to make sure that this person will not need a help of another person or will just basically be guided by technology. We can predict when the particular person needs to go to a doctor before that cancer cell will explode inside the body. So predictions are a really good thing if we use them wisely. I really like that comment that the authors gave in this particular section of the book, then the cost of a prediction is dropping down. Why? Because huge companies, Apple, Microsoft, Facebook, IBM, and others, they can afford a lot of computing power. They can buy this. Smaller companies that are looking into niche solutions, that are looking for the AI for good, they cannot do it. So when the cost of the prediction was dropping down, that means that the prediction assistance assisted by AI can be actually available to everybody. I also like one thing about it, that if there is a scientist that is responsible, like this given example from Canada, they were able to train algorithms called ImageNet, pool of pictures, and train them for good. They wanted to make sure that the next prediction will be better, just so other people can use that. Can you imagine if we can train the algorithms to recognize that the skin cancer is there without the doctor check, or I can take a picture of my skin change and do the pre-analysis at home to make sure that that cell is not going to be cancerous. I love that part of the prediction, and I love those scientists that are doing that for good. And I really hope that we will put even more efforts into building AI that will serve good predictions for good matters. Thank you so much for being here. If you like it, please subscribe. If you have comments or you want me to improve something, please put comments underneath this podcast. I would love to hear from you. Have a great night and thank you. Bye bye.